Hello, Sam fans, and welcome to this edition of Sam Science GCSE Physics, where we're going to be covering Newton's laws of motion in 7 minutes. This is paper 1 on Edexcel and paper 2 in AQA. Before we start, we just need to make it clear that physics, no one really likes physics, let's be honest here. And to describe physics in a meme, I'd say it's all here, using extremely long and complicated formulas to describe how a ball rolls. We will not be using, thankfully, any complicated formulas to describe anything in this particular video. Let's get cracking. So first law is Newton's first law of motion is the law of inertia. And I'll talk about what this word inertia means in a moment. So an object continues in its state of rest or uniform motion in a straight line unless acted upon by an external force. What the hell did you just say there, Sam? What is this lingo? I don't get this. So in easier terms, what that means is if force is acting on an object of balance, then it will remain still and not move unless there's a force outside that will allow it to change. And the other part of that is that if an object is moving and it keeps moving at a constant speed, meaning doesn't get any faster, doesn't get any slower, in a straight line, it will continue to move unless there's an external force that interrupts its constant speed. Let's have a look at some examples. So this guy here, cycling, he cycles at constant speed, not getting any faster, not getting any slower. Then what happens? Another force externally comes along. So this box, for example, he hits the box, comes to a stop. Therefore, he is no longer moving at a constant pace because an external force has come along and stopped him. Similarly, in this example here, you've got this bloke here sitting watching TV. He will stay watching TV and remain watching TV unless there's an external force from the outside to wake him up or move him to tell him he needs to move. In this case, his partner's come along with a frying pan and she's going to smack him to get him to move. Otherwise, if she doesn't hit him, he's not going to move. Just like if an object remains at rest, the object will not move unless there's another force coming along to interrupt it and make it move. This is also called law of inertia, and inertia simply means not wanting to change what you are doing. Meantime, had to be done. Want to lose weight? Go to the moon. Going on a diet makes you lose mass. This would actually make sense if you actually know the difference between weight and mass. And if you don't know, check my video out on weight and mass on my YouTube channel. And in case you're wondering what I look like as a bit emoji, that's what I look like there. Moving on. So if you want to have a go at this activity, pause the video now so you can complete it. Otherwise, Newton's second law pretty much states that when an unbalanced force acts on an object, the object is accelerated, meaning it gets faster in the direction of the force that is moving. The acceleration is directly proportional to the force, but it's inversely proportional to the mass. Simple terms, F equals ma. Okay, this I think second law is probably the hardest of the three because it says a lot in a couple of sentences. So real talk, Sam, what did you actually just say there? So in simple terms, Newton's second law says that when a constant force acts on a massive body, it causes it to accelerate, meaning to get faster at a constant rate, and it will remain at that constant rate. Now, if the mass of an object were doubled, so if it was to get bigger, its acceleration would be half. Why? It's simply because you've got more mass, therefore it takes more force to move it, therefore it will be slower. Okay, so if you look at the pictures I've got at the bottom here, we've got mass. He's pushing a ball of 400 kg and he's really struggling there to push it. Okay, he's putting more force in, but the ball rolls slowly. Similarly, you've got a smaller ball of 40 kg. He's happily rolling it along. Why? Because it's not very, this hasn't got a larger mass, but also as well, he doesn't need to put in a lot of force. Okay, so a force applied to an object at rest causes it to accelerate in the direction it's actually moving. Okay, so in this case, it's right to left. Okay, so acceleration is essentially cut in half. All right, that's simply because the mass is larger. And the word inverse simply means the reverse of something, or it's the opposite. Physics, well, if this guy Newton didn't come along, you know, it wouldn't be this difficult to have to go through. So if you slept under a coconut tree, you know, physics would be a breeze. Finally, Newton's third law, for every action is an equal and opposite reaction. And I would say that this is probably the easiest of the three to remember. So if the wall did not push back on Humpty Dumpty, what would happen to Humpty Dumpty, if the wall didn't push back? He would fall, exactly. So the force that the wall is pushing on Humpty Dumpty is exactly the same as the force that Humpty Dumpty is putting on the wall itself. So for every action, there is an equal and opposite reaction. Here's another example. Don't know why there's a ghost on the skateboard, but I thought that was a really good example. So this guy is pushing on the wall, and the wall is pushing exactly the same force back on the person, hence why he has not, or she has not, fallen over. If the force of the wall was not equal and opposite, then the person would fall over. But in this case, he hasn't, or she hasn't fallen over, therefore the forces are equal with one another. Thank you very much, Sam fans, for watching. Please make sure that you like the video and check out my other videos on my channel, Sam Science Physics. Thank you very much, fans.